Hey guys, welcome back to another video. Today we're going to complete part 2 of general form for the RF67 outcome. If you haven't watched part 1 yet, go ahead and click the little pop-up link on your video to go and look at part 1. So in this example, we're given 3 graphs and we want to come up with a linear equation in general form. What we want to do first is identify what's going to be easier for me to work with. We've talked about slope-intercept form and point-slope form. So we can use either one of those to start off with, and then from there we're going to convert it into general form. So in this first example, let's go ahead and use slope-intercept form first. So we've got y is equal to, y is equal to mx plus b. So you want to identify 2 things. You want to first figure out what the slope is, and then we want to figure out what our y-intercept is. So for us, our y-intercept is fairly straightforward. It's going to be right there. It's where our graph crosses the y-axis. So in this case, our b value is a -4. And to figure out the slope, again, we've done a lot of practice with this. We want to pick 2 lattice points, so we can start right there. And then let's use this lattice point right there. And we can see pretty quickly that our slope is going to be 1 over 1, or really just 1. So for us, our slope-intercept form will end up being y is equal to 1x, or just x, minus 4. So to turn it into general form, you notice that we want to make sure that our x is positive and that's a whole number. There should be no fractions or decimals anywhere in my equation, so I don't. The only thing I need to do is move everything onto the right hand side. So I'm going to move the y by subtracting y from both sides, and I have 0 is equal to x minus y minus 4, and that gives me my general form there. For example number 2, if you don't like using slope-intercept form, you can definitely use point-slope form as well. Both are perfectly acceptable to use. So remember, slope or point-slope form is y minus y1 is equal to m times x minus x1. So we want to figure out a couple things. We want to figure out what that slope is. And then we want to figure out what our 2 values of y1 and x1 are. So first of all, let's identify our slope. So we're going to pick 2 lattice points. So let's choose this one right here. Let's go here and here. So we've got our 2 lattice points, and we can go ahead and we can see that our slope, our rise over run, is equal to -1 over 2 for this particular example. So that means that m is equal to -1/2. For our x1, y1, let's go ahead and use this value right here. So we know that we have a point at 4, -3. And we could really use any point that we want. We could have used that 2, -2. You could have used 0, -1. Just any point will do for your x1, y1. So we're going to go ahead and substitute in our values. So we know here we've got y minus the -3 is equal to -1/2 times x minus 4. So let's clean it up a little bit. Y plus 3 is equal to -1/2 x minus 4. So this would be our point slope form. So you can see here that we're going to end up having to do a lot more work. Okay, but that's all right. So we're going to end up multiplying everything by 2. So let's multiply everything by 2. So that means both the left and the right side, we're going to multiply everything by 2. And we'll end up with 2 times y plus 3 is equal to negative 1 times x minus 4. Let's go ahead and simplify everything. We're going to distribute that 2, and then we're going to distribute that negative 1 to everything. So we'll have 2y plus 3 is equal to negative x plus 4. So to ensure that our x value is positive, so right now we have a negative 1x, we're going to move everything over onto the left side. So we're going to add x, and we're going to subtract 4 from both sides. So our final result will end up with x plus 2y minus 1 is equal to 0. So hopefully what you can see here is we can use a second method to figure out what our general form is. But comparing from example 1 to example number 2, example number 2 does take a little bit longer. Again, it just depends on your own personal preference, what you'd like, and so on. Example number 3, we're going to go ahead and go back to slope-intercept form. That is also my preferred method. We're going to go and figure out what our slope is. So our slope, we're going to choose 2 lattice points. So let's choose this one here, and we're going to go and choose this one there. So from there, hopefully you guys can see that our slope will be negative 1. And let's use our y-intercept. We know that b is equal to positive 5. So starting us off, we know that we have y is equal to mx plus b. We know that m is a negative 1, so negative x. And then our b value is plus 5. We know that our x has to be positive, so we're going to add x and then subtract 5 from both sides. So we're going to have x plus y minus 5 is equal to 0. For these 3 examples, I'm going to continue to use slope-intercept form. So for this one on the left, we've got y is equal to mx plus b. So we're going to go ahead and identify what our slope is. So let's pick 2 lattice points. I'm going to use this one here, and I'm going to use this one over here. So we can figure out that to go from this point up to that point, we're going to need to go 3 up and then 5 to the right. That means that our slope is 3 over 5. And then our b value, of course, is going to come straight from that point right there. And we know that b is equal to a negative 3. So I'm going to go and slot that right in. So y is equal to 3 over 5x minus 3. So you can see here that, that our issue is that we have a fraction, and we want to get rid of that fraction. So we're going to multiply both sides by 5. So we're going to multiply the entire thing by 5. We'll have 5y is equal to 3x minus 15. So since our x is already positive on the right side, we're going to move that 5y over to the right by subtracting 5y from both sides. So we'll have 0 is equal to 3x minus 5y minus 15. Example number 2 on this page, and maybe I'll identify my y-intercept first. So my y-intercept gives me a b value of positive 5. Our slope, we can use that as a lattice point, and we can use that as a lattice point as well. We know that our slope is going to be a negative 5 over 4. Because we are moving 5 down and 4 to the right. So using y is equal to mx plus b, we're going to substitute in our values. Y is equal to negative 5 over 4x plus 5. And we are going to multiply both sides by 4 because we want to get rid of this fraction here. So everything gets multiplied by 4. And let's do this in a green. So everything gets multiplied by 4. So I'll multiply this by 4 and multiply all of this by 4. So 4y is equal to negative 5x plus 20. Now because we have our negative 5x on the right hand side, we're going to move everything over to the left by adding 5x and then subtracting 20. And we have a general form equation that represents this graph. Last but not least, we're going to look at example number 3 on this page. So we're going to identify your b value as a negative 5. And then your slope, we're going to look at 2 of your lattice points. Oops. B is equal to negative 5. So our first lattice point, we can just use our y-intercept. And your second lattice point, we're going to go ahead and use this one. So we can quickly see that your m value is equal to negative 1. So this one's nice and easy. Y is equal to negative x minus 5. So we'll end up adding x and adding 5 to both sides. X plus y plus 5 is equal to 0. So now we're going to go back and we're going to look at parallel and perpendicular lines. So just recall from RF3, that was our unit about slope, that we discussed 2 different types of lines relating to slope, perpendicular and parallel lines. They have 2 unique characteristics. The first one being that your parallel lines are going to have the same slope. Okay, so what that means for us is if we have 2 lines on a graph somewhere, that red and that green line, they are both going to have the exact same slope. On the other hand, perpendicular lines are essentially the opposite of parallel lines. They will touch, they will meet, they will intersect, and their slopes are going to have negative reciprocals. So again, a really quick refresher here. Let me do that in black. If we have parallel lines, it essentially means that those lines are going to meet at a 90-degree angle. And the only way they're going to do that is if their slopes are negative reciprocals. So remember, negative reciprocals are 2 numbers that when you multiply them together, they will give you a product of negative 1. So for example, if I have a slope of 1/3, my negative reciprocal is going to be negative 3 over 1. Let me move that up a little bit so I'm out of the dead pixels. Negative 3 over 1. So essentially what I did was I had to switch the numerator and the denominator. So the top and the bottom numbers switch places. And if the first number is positive, the second number has to become negative. Another example is if we have a slope of negative 4/5, then our negative reciprocal has to be a positive 5 over 4. All right, so if you're having a little bit of trouble, make sure to go back to the RF3 notes or drop me an email. I'd be more than happy to help you out. So understanding these properties of parallel and perpendicular lines can actually help us figure out a second equation or a second line that we can make parallel or perpendicular to some sort of given line. So let's jump right into a couple of examples. So we're being asked to come up with a line that is parallel to the line y is equal to 5x minus 3, and it passes through the point 2, 8. So we understand that if something is parallel, we need to make sure we have the exact same slope. So that means in our second line, our given, or our parallel line, we're going to need to make sure that our slope is also 5. On the other hand, we're also going to examine our x and our y values. So we know that our x1 has to be a 2, and our y1 has to be 8 in this example. So let's go ahead and fill those in. So m has to equal to 5, x1 is 2, and y1 is equal to 8. So we're going to go and use point slope form. And this is one of the benefits of point slope form. As long as we know the slope and we're given a point, we don't need to worry about finding the y-intercept or anything. So point slope form is quite useful for this type of situation. So remember, point slope form is y minus y1 is equal to m times x minus x1. So we're going to go ahead and fill in those values. We'll have y minus 8 is equal to 5 times x minus 2. And just to make sure we understand where all those numbers are coming from, my 5, which is my slope, it's going to come and pop in right there. My x1 is going to pop in over there. And finally, my y1 is sitting right there. So this equation, the y minus 8 is equal to 5 times x minus 2, would give us an equation of a line that's parallel to y is equal to 5x minus 3, and it passes through 2, 8. In the second example, we're looking for another line that is perpendicular to y is equal to 5x minus 3, and it still passes through that same point, 2, 8. So we need to understand that a line that is perpendicular to this line, okay, so our original line has a slope of 5. That means that our negative reciprocal is going to end up being negative 1/5. So negative 1 over 5. Negative 1. And let me get out of the dead pixel space here. Negative 1 over 5. Now we want to use point slope form again and use that point 2, 8 to help us figure out where to fill in those numbers. So here we've got y minus y1, so y minus 8, and then is equal to m, which we know is negative 1/5, times x minus 2, and that will give us an equation that's perpendicular to y is equal to 5x minus 3, and it passes through the point 2, 8. Let's work through a couple more examples here. So some extra practice that you guys might want to try out is located on page 374 of your textbook. Questions 20 to 25. Try those out, see how you do. So the first example, we're looking for the equation of a line that is parallel to y is equal to 2x, and it passes through the point negative 1, 4. So in the original equation, we know that the slope is 2. So that means that the perpendicular slope, or sorry, the parallel slope, and that's what that little symbol there is. So the perpendicular slope, not the perpendicular slope, the parallel slope has to equal to 2 as well. We're looking to substitute in the point negative 1, 4, so that means that our x1 has to be negative 1, and our y1 has to be a positive 4. So let's go and substitute those in. Y minus 4 is equal to 2 times x minus a negative 1. So x minus a negative 1 As you can see, I've got a lot of dead pixels over there. Yeah, maybe I'll move that down a little bit. So x minus that -1. So we can go and simplify. Y minus 4 is equal to 2 times x plus 1. And that will be a linear equation that is going to be parallel to y is equal to 2x plus 9. And it passes through the point -1 and 4. So just to give a visual what that'll look like, if we were to quickly sketch the original. So the original graph, if I were to sketch this, or the original line, 2x plus 9, you have a slope of 2 and a y-intercept of 9. So it'd be something like this. So roughly something like that. And now the next line, y minus 4 is equal to 2 times x plus 1. It passes through the point -1, 4. And we know it's also going to have the same slope, a slope of 2. So we're going to go and look for a slope of negative, or a point -1, 4. -1, 4 is probably going to be somewhere around here. And we know that a slope of 2 should look something like that, giving us 2 parallel lines. Next, we're going to look for a line that's perpendicular to this line, y minus 4 is equal to 3 times x minus 2, and it passes through the point -5, -2. So first of all, we're going to go and see, or I hope you guys noticed that the slope is a positive 3 for the original line. So that means that our perpendicular slope has to be a -1/3. We're also told that it passes through the point -5, -2. So that means that my x1 is -5 and my y1 is a -2. So we're going to go ahead and plug those into our point slope form. Y minus y1 is equal to m times x minus x1. We can substitute in those points. Y minus a -2 is equal to -1/3 x minus a -5. So we'll end up with y plus 2, because when you subtract two negative numbers, we're going to end up adding them, is equal to -1/3 times x plus 5. So this would be a line that is perpendicular to the line y minus 4 is equal to 3 times x minus 2. In example number 3, we're looking for a line that is parallel to 3x plus 5y minus 8 is equal to 0, and it passes through the point 3, 7. So one disadvantage of general form is it doesn't necessarily tell you the slope right off the bat. So we're going to go and convert this into slope-intercept form. I'm going to do that by isolating y, or moving y to one side by itself. So I'm going to subtract 5y from both sides, and I'll end up with 3x minus 8 is equal to -5y. And then I can divide both sides by a -5. So divide by -5 and divided by -5. So finally, we're going to end up with a -3 over 5x plus 8 over 5 is equal to y. So the important piece of information that we get from here is really just the -3/5. The -3/5 will give me my slope that I need, and it just means for us that we're going to end up using the same slope. So your perpendicular slope is equal to -3 over 5. We're going to use that 3, 7 as our x1, y1, and we'll end up with y minus 7 is equal to -3/5 times x minus 3. In example number 4, we're looking for some another line that's going to be perpendicular to the line y is equal to 8x plus 1, and it has an x-intercept of positive 4. So this is tricky for different reasons. The first part, it's a little bit deceiving. We see that we're looking for a line that's perpendicular, So it has to be perpendicular to a line with a slope of 8. So what you guys hopefully have noticed is that the perpendicular slope is going to be negative 1 over 8. So again, if your slope is 8 over 1, the reciprocal is 1 over 8. And because we want to make it the negative reciprocal, we're going to pop the negative up there. Now the part that throws people off is we're giving you guys a value here, an x-intercept of 4. Well, this actually gives us a point. Our point is 4, 0. And that's a part that a lot of students usually miss. They tend to forget that when we're giving you an x-intercept, it actually gives you a point with an x and a y value. So 4, 0 is the actual point we're going to use. If we plug that into our formula or into our point slope form, we'll have y minus 0 is equal to negative 1 over 8 times x minus 4. So this would be an equation of a line that's perpendicular to y is equal to 8x plus 1. And this new line has an x-intercept of 4. We're going to move on to some linear equations in context. So again, the whole idea of using math is to be able to apply it in real life. There's no point using mathematics in a vacuum. So we want to be able to find contextual situations where it makes sense for us to apply these ideas we've been learning about. So here we have a question about Kareem. So Kareem is trying to join a local gym. He has to pay a startup fee of $99 plus a monthly fee of $29. So these are two key pieces of information. So your startup fee, okay, is your fixed cost. Okay, now we talked about that fixed cost back in RF 1, 2, and 8, and we also discussed it a little bit in RF 3, 4, and 5. And that startup fee is essentially your y-intercept. So you can go ahead and say that that's your y-intercept. So your y-intercept is b is equal to 99. And plus your monthly fee. This is something that increases every single month. So anytime you guys see a type of monthly or daily fee or whatever, when it comes to these types of problems, instinctively you should be thinking that is going to represent my rate of change or my slope. So rate of change, you're going to end up paying $29 per month. So for every 1 month, you're paying $29. And this is going to represent your M value. So we're going to write an equation for the total cost, C dollars, for N months at the gym. So we're going to go ahead and model y is equal to mx plus b, but we're going to change things up a little bit. We know that our y is really just going to be our cost now, so we can say that it's going to be C is equal to m, and we know that m was equal to 29. Instead of x, we're going to have n plus your $99. So C is equal to 29n plus 99. So that would be an equation that represents this whole model of paying for things at the gym. Now, if Kareem is going to the gym for 24 months, or 23 months rather, we know here that n has to equal to 23. So what is the total cost? Let's go ahead and plug in 23 for n. So we have our original equation. C is equal to 29n plus 99. C is equal to 29 times 23 plus 99. You can go ahead and pull your calculators out. So 29 times 23 gives me 667. And we add 99 to get 766. So we have C is equal to 667 plus 99. and we get 766. So what I tend to like getting my students to do is to write a little sentence at the end so that they can show me they understand exactly what that value represents. So you can say it costs $766 to go to the gym for 23 months. You can probably just work out at a home gym for much cheaper, aka free. So now we're going to suppose the total cost was $505. So here we're being told that C is equal to 505. For how many months did Kareem use the gym? So now we're being asked, what is N? So we're going to go ahead and isolate for N in this situation. So again, we start off with C is equal to 29, N plus 99. You want to plug in everything that we know. So 505 is equal to 29N plus 99. I'm going to subtract 99 from both the left and the right side because, again, my goal here is to get this 29N by itself, and then after that to get the N by itself. So 505 minus 99 is equal to 406. So 406 is equal to 29N. And then I'm going to divide both sides by 29. So 406 divided by 29 gives me 14. So 14 is equal to N, or N is equal to 14. So we can say Kareem used the gym for 14 months. He used the gym for 14 months. Now we're being asked, can the total cost be exactly $600? And we want to be able to justify our answer as well. Here, once again, we're going to go, we do know what cost is. We're being told that the cost is $600. So again, we're going to look for N. What does N equal to? So let's start that off. So 600, and maybe we'll just start off with the original equation. C is equal to 29N plus 99. So we'll have 600 is equal to 29N plus 99. If we subtract 99 from both sides, so minus 99, we'll have 501 is equal to 29N. We're going to divide both sides by 29 because I want to isolate for N. And I will end up with $17, or not $17, 17.275. So let's just say 17.28 is equal to N. So from here, you want to be able to get a couple pieces of information. The first thing is that the number of months is 17.28 roughly. Can we ever pay for 17.28 months of gym membership? And the answer would be no. You pay monthly for your gym memberships. You pay every full month. You don't pay 0.28 of a month. So unfortunately, no, the total cost can't be $600 because you can't pay for partial months. You can't pay for partial months. Our next example here, we're talking about an electrician, and she charges $80 plus an $80 initial fee plus $50 for each hour that she works. So let's go ahead and identify what does each thing represent. Well, your $80 initial fee is your B value, so your B value is equal to 8. And you're being charged $50 for each hour. So that means that your slope is going to be 50. So we're going to write an equation to represent the total cost for your hours of work. So using your slope intercept form, y is equal to mx plus b, we can go and represent this using those variables c and t. So this would give us c is equal to 50 instead of x. We're going to have 50t plus $80. So essentially what that means is if you want to get this electrician to come out to your place, it's going to cost you $80 up front before she even does a single thing, and then $50 an hour thereafter. How would the equation change if the electrician charges $100 as her initial fee plus $40? Again, this initial fee is just your B value, so in this case B would be 100 and M would instead be 40, and we'd end up with something like C is equal to 40t plus 100. So we're going to create a graph representing the first 4 hours that she works. So we can go and start off with a label here, and we can say hours worked or amount of pay versus hours worked. Versus hours worked. Now we're going to go and make a graph here. Let's start off here at 0. And we know that at the bottom, we are going to be looking at hours. So let's say that every 2 is going to be 1 hour. And then along the side here, we're going to go up. And if we're looking at the original one that we worked with, C is equal to 50t plus 80. Let's go up by we can go up by roughly, let's say 40. Okay, so let's say every 2 here, maybe not 40. Let's go up by 20s. So every tick ends up being 20. So we're going up, and we've labeled everything. So again, pick a scale that's appropriate for your situation here. And we know that because our B value has to be at 80, we're going to start off our first point. So at 0 hours worked, she has already made $80. After 1 hour, she's going to earn another $50. So if every tick is 20, every half tick is 50. So we're going to go up 20, 40, and then about right there. We're going to add another 50. So 10 plus another 2 lands us over there. And then we're going to end up over here. And then finally, let's go right up to there. And I need to add one more to 280 here. So this is a graph that represents the first 4 hours that she works. And again, we can go ahead and we can connect those with a straight line if we'd like. It just really depends if she's going to charge fully by the hour or if she's going to charge, you know, per 10 minutes, per half hour. Generally, we can just represent these using a straight line as well. The third practice question, or the third word problem, asks us to figure out a question using the speed of sound. So when the air temperature is 10 degrees Celsius, the speed of sound is 337 meters per second. And when the air temperature is 30 degrees Celsius, the speed of sound is 349 meters per second. So we need to write some sort of linear equation to represent this function. There's a couple things that we need to do first. We need to identify, what do we do with all these numbers? First of all, we need to ask ourselves, which variable is dependent on which? Does the temperature affect the sound, or does the sound affect the temperature? So in this case, the temperature the speed of sound is dependent on the temperature. So the hotter it's getting, it looks like the faster that sound will be. Okay, so your speed is going to be your dependent variable because it depends on the air temperature. So we can actually come up with two data points here. The first one being 10. So you've got 10, 337. And your second point being 30, 349. So you can figure out what our slope is between those 2 points, because we do need that to come up with a linear equation. So we're going to label this x1, y1, and then x2, y2. So this will give us m is equal to 349 minus 337 over 30 minus 10. So this will give us 12 over 20. And we end up getting, this can reduce to 3 over 5. All right, so our slope ends up being 3 over 5. We can use some sort, or one of these 2 points as our x1, y1, and we're actually going to use point slope form. So remember, we got y minus y1 is equal to m times x minus x1. So let's go ahead and use the 10 and 337 as our randomly chosen point. We could have used the 30 and 349 as well. It doesn't really matter. And once we sub in those values, y minus 337 is equal to 3 over 5 times x minus 10. So there is a linear equation. So like I've mentioned in the past before, it really just depends on the situation. Would you use a slope-intercept form? Would you use general form? Would you use point-slope form? And just whatever is more comfortable and which one's more efficient in each situation. Could we have found the y-intercept? Yes, absolutely. It would actually involve another step. And again, we try to be efficient as mathematicians. So we're going to use that equation to find out what happens if the temperature is 0 degrees. So here we're going to basically say that this x ends up being 0, and we're going to try to figure out what this y value is equal to. So we're going to substitute that 0 in. So we got y minus 337 is equal to 3 over 5 times 0 minus 10. So we have 3/5 times negative 10. So we'll have negative 6 on the right-hand side. And as we continue down here, we're going to add 337 to both sides. And we end up with 331. So that means that when the temperature is 0 degrees Celsius, the speed of sound is 331 meters per second. Now we're going to look at one final example before we close this video off for today. And this one will give people some troubles. So please try this one out on your own first before continuing on. So this example here, we're given a question where it says peanuts cost $2 per 100 grams and raisins cost $1 per 100 grams. Devin has $10 to purchase both of these items. So we want to generate some data first for this relation. So what that means is we need to ask ourselves some hypothetical questions. So if we do this, we can do that. If we grab this, then we can grab that. So let's say, for example, we want Charles is going to buy, let's say, no peanuts. Okay, so we can say that peanuts will represent my x values, or my x values. Maybe not my x value. Let's call this P. And we'll do R. So we can do P and R. So if Charles buys no peanuts, then that means that Charles can buy 1,000. That is not 1,000. 1,000 grams of raisins. On the other hand, if Charles buys 0 grams of raisins, Charles can buy 500 grams of peanuts. We could do something in the middle, but we're just going to use 2 points just for efficiency. So we got 2 points there. We want to use this to graph the data. So let's come to the bottom. And we can, and maybe I'll give myself a little bit more room here. And let's give this graph a nice title. Let's say peanuts versus, or amount of peanuts versus raisins purchased. So we can say grams of peanuts versus raisins purchased. And we'll start here. And let's go, each one of these can represent, I don't know, roughly 100. So let's go 200 for 2 ticks in, 400, 600, 800, and so on. And we'll do peanuts down here. And we'll go raisins up over here. And again, we're going to go every 2 ticks is 200. And we can plot our 2 points. So when there were 0 grams of peanuts, we know that there were 1,000 grams of raisins. And when we know that when there were 0 grams of raisins, there were 500 grams of peanuts. So we can actually go ahead and draw a straight line from one point to another. And it'll look something like so. So you want to write an equation for this relation in general form. So a couple different things that we could do. We could look back at our y-intercept. So in this case, our y-intercept is at 0, 1,000. I'm really struggling with the number 1000 today. 0, 1000. So that means that my B value is equal to 1000. So B is equal to 1000. Now the next thing that we need to figure out is the slope. So we need to have our 2 points, and we can figure out the slope using those 2 points. So we know we've got 0, 1000, and we also have 500, 0. So we can use that as our x1, y1, and our x2, y2. So you've got slope is equal to 0 minus 1000 over 500 minus 0. And we know that we've got negative 1000, negative 1000 negative 1000 over 500, which means that I have a slope of negative 2. So my slope there is going to be negative 2. And we can go and substitute that into slope-intercept form. So y is equal to negative 2, or maybe not y. Let's go and use our formula here. You have r is equal to negative 2p plus 1000. Now, if we want to make sure that we have general form, if we take r as our x, or sorry, if we take p as our x value, and we know that it's going to be our x, or our deep or independent variable, because it's on our x-axis, we're going to move everything to the left side here. So we're just going to add 2p to both sides, and we're going to subtract 1000 from both sides. All right, so we have 2p plus r minus 1000 is equal to 0. So that would be our equation in general form. Now, the last couple things that we need to answer are, will Charles spend exactly $10 if he buys 300 grams of peanuts and 400 grams of raisins? Well, there's a couple different things that we could do. We can substitute in those different values. Some people might say, hey, we can actually just calculate it by hand, but we're going to use that formula that we figured out. So 2p plus r minus 1000 is equal to 0. So let's see if that works out here. So we'll have 2p plus r, maybe I'll write it down at the top, 2p plus r minus 1000 is equal to 0. So in this case, p is going to be equal to 300, and r is equal to 400. So we'll have 2 times 300 and excuse all this technological trouble. I'm trying to avoid all these dead spots on my screen. So we got 2 times 300 plus 400 minus 1000 is equal to 0. So he will spend exactly $10 if the left side is equal to the right side. Let's see what happens. 2 times 300 gives me 600 plus 400 minus 1000 is equal to 0. 600 plus 400 gives me 1000. 1000 minus 1000 is equal to 0. So the answer to this question is yes. He will spend exactly $10 if he buys 300 grams of peanuts and 400 grams of raisins. Now we're being asked, what happens if he buys 400 grams of peanuts and 300 grams of raisins? So now in this case, we're going to have 2 times 400 plus 300 minus 1,000. And I am really struggling with that 1,000. Holy cow. Minus 1,000 is equal to 0. We'll have 800 because 2 times 400 gives me an 800 plus 300 minus 1,000 is equal to 0. So this will give me 1,100 minus 1,000 is equal to 0. So I'll have 100 is equal to 0, which is not true. So the answer here is no, he will not spend exactly $10 if he buys 400 grams of peanuts and 300 grams of raisins. The last portion here, again, just a throwback to domain and range. What's the domain and range of this particular linear relation? Maybe just to kind of go back here. Can we connect the points? Yes, absolutely, because Charles can buy any combination of peanuts that he wants. Doesn't really matter. So for us, our domain and range, if we were just to quickly go and write that out, we would have your domain be anything from 0 to, in this case, 500. So P has to be greater than or equal to 0, less than or equal to 500. And your range for your raisins, we're going to go anywhere from 0 to 1,000. And that's the end of today's video. Again, make sure to watch part 1 if you haven't already watched part 1. And watch out for the next video lesson. Check D2L whenever possible. Make sure you like the videos, subscribe to them, subscribe to the channel so you get the latest notifications. Until then, keep washing your hands.